Hello everyone, my topic is traffic sign recognition. In this project, we train a deep learning model to perform traffic sign recognition on Google Colab. We explore image data preprocessing techniques, network configuration, and hyperparameter tuning to achieve an accuracy of 98.2% on the testing sets. We use PyTorch and PyTorch Lightning as the programming tool. We have three parts for this project. The first part is image preprocessing. And we use GTSRB dataset as our dataset. There are over 50,000 images in 43 classes. And due to class imbalance in GTSRB dataset, we initially planned to use weighted random sampler to reduce the modal bias. However, the dataset was captured during driving and represents real-world likelihood of classes. Classes are assigned a similar ratio in train test and validation test set. There is no bias in this situation, so weighted random sampling step is skipped. This is the distribution of our dataset. And there are 4 steps for image preprocessing. The first step is resize. In our project, images are resized to 32 by 32 pixels using touch vision. The second step is normalization. We can normalize the pixel value range from 0 to 255 to the range of negative 0.5 to 0.5 using to sensor and normalize to accelerate the training process. The third step is random center crop. We randomly capture the center square in 30 by 30 pixels and expand it to 32 by 32 pixels, generating more data to reduce overfitting. The final step is brightness normalization. We can use OpenCV to perform the brightness normalization. This graph is the comparison before and after the brightness normalization and center crop. Network configuration. We use the classic LANet model architecture as the starting point and inserted a spatial transformer network. The spatial transformer network allows a neural network to perform spatial transformations on the input image in order to enhance the geometric invariance of the model. The beauty of STN is that it can be plugged into an existing CNN with very little modification. And as shown below, it can crop a region of interest and scale and correct the orientation of the image to improve the model performance dramatically. This is the original images, and this is the transformed images. The comparison with LANet, we add dropouts and batch normal layers, replace the sigmoid activation function with ReLU function to increase the training speed. We replace the average pooling with max pooling, and also use the softmax function on the output. We use RGB 3 channels instead of the single channel input image. Hyperparameter tuning. The epochs, learning rate, batch size, and are tuned according to the computational speed and testing accuracy. It's a trade-off between the optimistic validation accuracy and the computational capacity. From this graph, we can see that our final learning rate is e to the power of -3. With this learning rate, the performance of validation accuracy is pretty good, and also the validation loss is the lowest. We choose 50 as our epochs. With these epochs, the performance of train and validation accuracy is good, and also for the train and the validation loss. The model testing. Our project is simulation based. We monitor training accuracy and validation accuracy during the training process to help us explore the art and science of hyperparameters tuning. When training is done, the model is tested on the testing set. The testing accuracy is 98.2%. Finally, we use our trained model to make predictions on new images found on the internet to investigate its real-world performance. We can see from this table there are 16 images, and they are all verified correctly. The conclusion: in this project, we proposed a model for traffic sign classification. The proposed model first uses pre-processing method to improve the image quality. Then it uses spatial transformer to help the model learn invariance, to translate translation, scale, rotation, and so on. We equipped a classic LandNet model with modern techniques. And finally, the algorithm we proposed reach 98.2% accuracy on testing set and performed as expected on web images. The future work, our model performs well on the GTSRB dataset. For the next step, we'll try to use a traffic sign dataset with better resolution. Once we switch to the bigger size dataset, there are some areas we want to continue exploring. The first one is traffic sign detection. We can include the knowledge introduced in ENGR501 to fulfill the traffic sign detection. One limitation is that it is computationally expensive. To speed up the search time in the future, we will try the fast auto augment. The second one is data augmentation. We can use the Augmix as the or it is a simple data preprocessing method to improve the model robustness, but it is available in PyTorch unstable version. The final one is the residual blocks. We will borrow the idea of residual blocks from the ResNet. It might help to solve the vanishing and the exploding gradient problems and allow us to train deeper neural networks without a huge loss in performance. That's all. Thank you.